every tool will have different strengths and weaknesses. And it doesn't really make sense to try to only use one and think that you're getting everything out of it. Because inside FB itself, there are different techniques that will maybe find different types of bugs or be able to prove different types of properties. And you should really use as many things as you can. And of course, if you have to install 10 different tools, you're not going to do it.
GM everyone, my name's Tagachi, the host of Scraping Bits, and today I'm with Leo Old. How's it going, Fran?
Hey, yeah, pretty good. Happy to be here.
Yeah, great to have you on. Thank you so much for taking time out of your day to come on. I know you're incredibly busy, so very appreciative of this opportunity. Just for the people that don't know who you are, I would love for you to give a short little intro of who are you and what do you do?
Yeah, for sure. So hey everyone, my name is Leo. I am currently the formal verification lead at the Ethereum Foundation, but also working on ZK VMs on Powdr, and I've worked on the Solidity compiler before. I guess that's the things people will relate to.
Yeah. Before joining, the Ethereum Foundation as the lead FV guy, I guess, how do you even get to a position like that? Where did you come from and kind of progress your career into where you are now, working on ZK, co-founding that?
Yeah, so I did my PhD in SMT solving and formal verification at that point. It was not necessarily applied to Ethereum or smart contracts. I went into that field because I was interested both in theoretical computer science, the complexity in these things and logic, but also in applying that stuff to systems. So not only staying theory, but also not only staying experimental. So this is a field that I felt like had all the things that I wanted. And during my PhD, we were building tooling for software verification, software and hardware verification, a bit more focused on software. And then at the end of my PhD, pretty much, even before that, me and friends were always into Bitcoin. And then I had a friend who was really into Ethereum. And then we got into smart contracts, started just writing smart contracts for fun. And then at the end of my PhD, I started trying to apply the knowledge we had on software verification to smart contracts. And that's when Christian from the Solidity creator and back then the Solidity team lead invited me to go work with them.
Mm-hmm. Okay, got you, yeah. And so how did you kind of know Christian at all?
I didn't.
Oh, okay.
Yeah, I just started writing tooling for smart contracts and just publishing it on GitHub, talking to people online. I was also often asking questions on the Solidity, back then GitHub channel on GitHub, and I started contributing to the compiler as well. So that's basically how we got to know each other and then had a conversation, and then I joined after that.
Open source tooling, powerful things like, FE, fuzzers, etc. If they're super powerful, most people would just close source them, right? So I guess it was early days, and building tooling for such a ecosystem in its infancy definitely would have sparked some interest within the that kind of community. So I guess open source is a really great way of getting recognition, right?
For sure. Yeah,
you're providing value in that sense, and then obviously people take notice and try and contact you and then give you opportunities. So I wonder why you chose formal verification over something like fuzzing.
For me, it was just natural because that was just what I studied and what I was familiar with. In our academic group at university, we were very focused on formal methods. So we had our own SMT solver and we had more that kind of tooling. And whereas I think fuzzing and automatic testing, these kind of things, sometimes people do all of these inside a formal methods group, but I think they are more common in a software engineering department or research group. And so it just happened that in my group, we were also a small team. So we were very focused on this one thing we were doing. And of course, I was familiar with fuzzing and I knew people working on fuzzing, but it was just, I just ended up doing FB instead.
Just for some context, what specifically is an SMT solver?
So an SMT solver is, more generically, it's an automated theorem prover. Theorem provers have existed for several decades now, and it started when mathematicians wanted to prove things automatically. So instead of you have a theorem, instead of trying to prove it by hand, you would apply mechanical steps and try to come up with the proof that a theorem is correct for all cases. Mm-hmm. Or find a bug in the proof, basically finding a rule that actually doesn't really apply. And of course, this started a long time ago. And if you think about systems like Coq or Isabel or Lean, these are more classic theorem provers, and they're not necessarily completely automated. They require some human assistance. So these are called assisted theorem provers. And SMT solvers came, or maybe like a generation after that, or a generation and a half after that, in which you have a language called SMT lib, which you can use to express different theorems involving different data types or different operations. And then the SMT solver will try to prove this, will try to prove the satisfiability of your statement automatically, fully automatically. And proving satisfiability means you give a formula, a Boolean formula that has to be true or false, and it will tell you whether this formula is satisfiable or not. Meaning, satisfiable meaning there is a valuation of all the variables in this formula that make it true, and unsatisfiable meaning this formula can never be satisfied, can never be true for any possible values that you plug in the variables here. And it turned out that SMT solvers were very good for software verification because they are fully automated in the first place, and because the way that you write theorems that this SMT solvers can understand is very similar to software. So the sub languages you would write are not like super complicated calculus and weird things. It's more just like it's very similar to programs. You would say a statement using variables, using integer variables or real variables, and make numerical statements about these variables or arrays, for example. So SMT solvers, they have logics, which consists of theories, and each theory gives you a certain sub-language to play with. So for example, integers. So you have a theory where you can have integer variables and integer operations. And then you have a different theory in which you have arrays. And arrays are parametric, that you can use any type as the index type or the value type of the array. And you also have array operations. So you can select an element from an index, you can store a value into an index, and you get another array out of that. So these sub-languages that were built with SMT solvers were kind of very natural for program verification. Plus a lot of practical advances in first SAT solving, which is just Boolean formulas. There's no theory element in solvers. And then SMT solvers, the practical advances that these solvers made in like the 90s or the 2000s and the last 15 years made them very practical for software verification.
Yeah, it's more of like a, I guess, mathematical way of proving something right instead of just kind of throwing random inputs and seeing what happens after.
Yeah, so the way you would model a program usually when you're using an SMT solver is so that you encode the program using this mathematical language that SMT solvers provide. Then you need a property. So when you're formally verifying something, you need a property that you want to either break or prove that it's safe. And this property is not only relevant for formal verification, but for anything, right? For fuzzing as well, for like Foundry calls, invariant testing, or also HVM. And it's just a property that you want to know or that you want to test, right? And for FE, this means it's a pretty extreme interpretation for FE in which you're either trying to prove that this property is correct for any possible input, even without actually testing all inputs, or if you can't prove it, it's going to try to give you a counterexample to that property, which is effectively a bug usually, right? It's something that breaks your property. And the way that you will, again, using SMT solver is by encoding the program, and then you take this property and you encode the negation of the property. And then you ask the solver, is this possible? Is it satisfiable? And the semantics of that are so that if the solver tells you this is unsatisfiable, it means that it's impossible for the negation of the condition you're trying to prove to be true. So it's impossible for the property to be wrong. Therefore, the property must be right. And if the solver tells you this is satisfiable, it's going to give you what's called a model, which is the valuation for each variable in the formula that make it true, meaning here is a way to break the property, to make the negation of the property be true, and effectively showing you how to basically break the property and basically giving you a bug, right? So this is the very basics of how an SMT solver is usually used for this type of analysis. But then, of course, there's a lot of different ways people can vary this technique and try out different things.
Right, yeah. So the SMT solver was really used for just making sure that the code was meant to do what it was meant to do, right? It wasn't really looking for security vulnerabilities, as in like reentrancy, for example.
You can use it for that too. There are different sub techniques inside FV that will be more efficient to either case. But there are techniques that will be more efficient when you're actually trying to break something. It's not going to help as much in proving that it's correct. But if it is broken, it's more likely to find the flaw than some other technique that is supposed to prove correctness of the property.
Okay, but for, Solidity, it was mostly just used for like non-security issues, right?
Yeah, it's still the case that FV usually you're trying to prove correctness, and
Yeah.
you can use FV, you can tweak it in a way that you're at the same time trying to find bugs, right? And it is true that what we see a lot in practice is that a lot of the bugs are actually found by other techniques, right? So fuzzing, for example, is a very successful technique in finding bugs because of the nature of the technique. And whereas FE, it's designed to prove correctness, and then I don't want to call it a side effect, but it is like it is kind of a side effect that you can also find bugs with it. The tools, they are all written with that in mind, that you will get bugs, you will get counterexamples for these properties and get bugs, but it is true that it's harder to do it with FV than other techniques. But it's also the case that many times some bugs might only be found by FE, similar to how some bugs may only be found by fuzzing. So these tools are quite complementary.
Coming from a fuzzing point of view, if you were to just try and find every possible bug, you would just brute force it, right? Every possibility, every single context instance, and you'll eventually find something if given a long enough time frame, or if it's smart enough to kind of minimize the time complexity issue. But yeah, if you complement them, then you're really hitting everything. But then that begs the question: if you've never done it, how would you really get into it, formal verification, without going to, let's say, university?
Yeah, I think it's a field that it's still mostly academic, the way people get into it. But I think especially on Ethereum, there's a lot of people without that background that know about it, which is pretty amazing, to be honest. And I think especially because the academic form verification community also gained a lot by Ethereum, because it's probably the first software community where FV is really applied. We have been trying to do this. I mean, FV has been applied in different ways, like especially hardware, especially like the medical devices and avionics industry. They do apply these things for like decades already. But in the software community, software was always too complicated to use these tools in like a day-to-day basis. And in Ethereum, it just exploded because there are a set of incentives that make FV very doable for Ethereum. So for once, the programs are small by nature, right? So the smart contracts are usually simple and they're small, both because for a practical reason on Ethereum, you have the bytecode size limit, right? And you also have gas itself, which gives an incentive for things to be small and simple. The second thing is obviously the financial incentive for things to be found early or for things to be hacked. And also the immutability aspect, right? Of course, people can upgrade contracts and do different things, but by nature, it's also immutable. So these three things together make FV very attractive for Ethereum, and we see it in the FV boom we've had in Ethereum the last years, with several tools, several companies doing these things, and also from an education point of view, where Solidity developers that had never had any background in form verification, they know about FV. They already used it via HEVM, for example, or now Helmos or SMT Checker or Manticore or Mithril. A lot of these tools, they apply FV methods, and people may have used them before. And I think Ethereum basically has this point of connection that is not unexpected, but definitely surprising for a lot of people.
Yeah, I imagine it'd be really hard to get into if you don't really have the academic background of math, for example. Like me trying to get into AI, I realize there's so much math involved, and it's kind of a hindrance if I want to get into designing models, for example. So I mean, it's a critical role in FE, isn't it?
Yeah, I
Having
think there's
PALs.
also a difference though in like if you're writing the FB tools or if you're just using them. If you're like, of course, to write these tools, you will need some background, potentially
Mm.
SMT solving or assisted theory improvers, kind of things. But if you're using the tools, a lot of teams, including ours, are working on making like the DevX or like the UX of these tools the best as possible, so that when
Yeah.
you use these tools, you don't have to know anything about the background. You don't have to know, like, basically making for
Hmm.
example, making the API the same as fuzzing, right? You're like,
Yeah.
here's a property, just try to break it or prove it correct. I don't want to know what's happening in the background. And that's what a lot of tools have focused on the past years.
Yeah, I completely agree. I think, tooling right now in Ethereum is very convoluted and it's very hard to get up and running without, doing a lot of research into it. The dev experience, and at least in my experience, hasn't been the best, so I've just never really used them. But obviously, if you just make it very streamlined, you just, for example, provide a property and then a contract, and then it just does it, that would be just, the best, right? There's no learning of, how do I set this up, or what do I need, all these dependencies. It's just you grab it, put it in, run it, and then there you go. But
Yeah,
yeah,
for sure. And one thing we've seen, especially last year and this year, is so adapt tools and HEVM, they kind of started this like
yeah,
FE integration into the development, right? And with HEVM back then already, adapt tools you could write invariant testing, you could do fuzzing, you could do symbolic execution, right? And
hmm,
Foundry went on a similar path, at least with fuzzing and the invariant testing, right? Which you can do with Foundry itself. And
yeah,
a lot of the symbolic execution tools and FE tools in general, they are providing Foundry integration, right? So if you take
hmm,
SMT checker, it can be used directly via Foundry. HEVM has Foundry integration. Helmos has Foundry integration. KEVM has a mode with Foundry integration. I think Sertora is working on Foundry integration. So a lot of these tools, they notice that the best way is to, sorry about that. The best way is to basically take what people already use, which is things like hard hat, Foundry, and so on, and
hmm.
integrate DeFi tools inside these development toolkits. And that's what provides the best UX to everyone, right?
Yeah, yeah, because it's such like a big ecosystem. Everybody already uses, for example, Foundry and Hardhat. Obviously, Foundry has gained tons of traction. It's kind of the standard now. So if you want to have a tool that everybody uses, you would obviously use integrate with the tool that everybody uses.
Yeah, because
um,
if you ask someone, yeah, go here, install HVM, and then install SMT checker, install Helmos, install Sertora Prover, install KVM, install everything, they're like, no one's going to do this.
yeah,
And it's one thing we usually tell people. They ask, oh, what's the best FB tool? What should I use? And you should use everything.
mm,
Every tool will have different strengths and weaknesses.
yeah,
And it doesn't really make sense to try to only use one and think that you're getting everything out of it. Because
hmm,
inside FB itself, there are different techniques that will maybe find different types of bugs or be able to prove different types of properties. And you should
hmm.
really use as many things as you can. And of course, if you have to install 10 different tools, you're not going to do it.
Yeah, exactly. Yeah, the installing everything is definitely something you don't want to do. You kind of just want like an aggregated source where you can just access them all at once, because it becomes this time kind of trade off with the person that's using is like, oh, okay, do I really want to use this? Especially if they're, for example, like a startup, right? They want to work on their startup and get to MVP and start releasing. They don't want to spend all these hours trying to learn how to install something, maybe an error comes up, they can't find the answer, it just becomes this very convoluted thing. Um, but that begs the question of when someone wants to build an SMT solver, how should they really go about the design phase and then implementation?
So I feel like you wouldn't go about writing an SMT solver. This is usually not something that a lot of people are doing. Even like people that are writing tools for smart contract firm verification, for example, no
Yeah.
one's really writing their solver. So these solvers, they're usually written by, they're like even a lower level in the stack.
Right.
We are using these tools that usually come from academic groups.
Right.
There are lots of these SMT servers out there. There are two main ones that almost everyone uses, called Z3 from Microsoft Research and CVC5 from Stanford University and a
Mm.
few others, I
Okay.
think. So these tools are like maintained and developed by these mostly academic or research teams. And the people that build FV tools for smart contract doing symbolic execution or symbolic fuzzing or different things, we basically use these solvers. Yeah,
Okay.
we wouldn't really write a solver ourselves. That's a lot of work.
It's just too, yeah, it makes sense. May as well use the standards unless you have, abundance of time to create your own. What led you to stop working at, Ethereum Foundation as like lead formal verification? Stop doing that and then moving on to, a different kind of path.
Yeah, so I've been interested in the ZK space for several years now. I was always trying to write circuits and learn about how these things work. And actually, 1.5 years ago, almost 2 years ago, we actually started a project for doing FV for ZK circuits. So basically, trying to write techniques based on SMT solvers or using SMT solvers or SMT solvers plus something else, such as like Grosvenor bases, more algebraic approaches. Applying these things to ZK circuits because these things were becoming really popular. And yeah, we wanted to bring the same type of techniques we have already in software or smart contracts to this space as well. So this is something we were actually focusing on inside our FA team in the EF itself. Mm-hmm. And so we were always close to the ZK space in a way, more from this like FV insecurity point of view, but at the same time also having a compiler background. So about 2 years ago, I think is when me and a few other people started digging a lot into ZK EVMs, pretty much just like understanding how would you go about writing, making ZK proofs about EVM execution. So we're just learning a lot about these things and becoming familiar with the project that we're doing this like 2 or 3 years ago, even though back then it sounded like it would still take a long time. So basically, yeah, studying these techniques, trying to design new techniques of how to make this happen. And yeah, and basically I always, especially last year, I was trying to do different things, to experiment with different proof systems, for example, because we hear a lot about like different proof systems. So you have Starks, eStarks, Halo 2, Nova, Supernova, the whole thing. And I wanted to experiment with all of them. And it was basically an impossible thing to do. It still kind of is. So this is a problem that, Christian and Thibaut, who started Powdr with me, also experienced. And we basically decided to jump on it, write some tooling, and then we had some really good preliminary results and eventually decided to just like jump on it full time and work on this as our main thing.
Now you're applying all your skills from Ethereum to now ZK. I guess what is your kind of end goal for Powdr?
Yeah, so currently we have, so the idea in Powdr, the tool itself, is to be a compiler middleware for many front ends, many back ends. So this is of course how compilers already work outside Ethereum or like outside blockchain, outside the ZK space, right? So you have things like LLVM, which accept many front end languages via LLVM IR. And then you have a single compiler pipeline through LLVM, which then can also give you binary or assembly in different targets. So like x86 or ARM or RISC-V, etc. So the idea of Powdr is basically very similar, where we want to be able to use any front end language through the same compiler middleware into any possible backend. The backends being the proof systems, right? And so basically being able to make proofs in different proof systems or even combine them, the recursion application, all those kind of things. And the way we do this is by writing a new language. So the Powdr IR basically is an assembly language that allows the users or also ourselves to write VMs in Powdr. Right. So we can basically write any VM in Powdr itself, and then with a simple transpiler from whatever front end assembly into Powdr IR, we basically can benefit from the entire workflow and the entire pipeline of the compiler, including static analysis, security passes, optimizations, all those kind of things. And at the same time, have access to a whole set of proof systems and aggregation.
Yeah, that seems like a lot of work as well, though. So I guess, how do you build all this stuff like an IR that's actually quite good? How do you make that effective as well? Because, people use IRs and security techniques as well, like fuzzing and all that stuff, to make it more simple and understand it. So even compilers will be the same of, checking for, any, I guess, mishaps in the code. But yeah, I guess, how do you really go about building this entire stack What's the process of it? Obviously, it's gigantic, so there's got to be some kind of structure. But yeah, how do you really design this whole architecture?
Yeah, it's actually not that big. It's really like it's all in the abstractions. So all you want to
Okay.
do is just like keep it layered and compiler passes. So you have several layers, several levels in the stack, and you just keep converting one to the next. And it's not like you need to have this one massive program that does everything. The key point is being very modular. So for example, we have the IR language, right, in which you can define VMs. And with this language, we wrote the RISC-V implementation, basically how RISC-V works, and like the instruction set, basically, in Powdr IR. We also wrote the Valida VM, and we're soon going to write like WASM as well and EVM, right? So
Nice.
this is written in the language as well.
Yeah.
And from that, we do several transformation passes into different flavors of the assembly itself, and then doing some different passes, optimization, and so on. And then finally, we arrive at a low-level constraint language, which doesn't have the notion of programs anymore. It only knows about constraints. At this point, we do a few more passes of optimizations and analysis and so on. And from this, it gets transformed into the shape that each proof backend wants. So this final part is actually pretty simple because we are already at a language which is just constraints, and the provers also take constraints. So it's more just like it's a like single file API where we just transform our data structures into the prover data structures. So this part is actually one of the simplest. And yeah, a lot of work actually goes into design of the language. So we had several designs, several iterations on the VM language basically, and we just keep changing it. And our idea is to be very iteration based. So we just write an iteration, and we're never really 100% happy with that iteration, but we go for it anyway. We change our tests, we change our code, and then we start writing new things, and then learn what we have to change next and keep changing these things. And one approach we have followed since the beginning is to focus on an end-to-end approach where even if not all modules in the middle are finished, we want to be able to follow an end-to-end path fully and at least attempt things. So that's why we decided on one front end, we decided on one back end, and then we said, okay, let's make this one path work, which was basically the RISC-V to actually two paths, RISC-V to Halo 2 and RISC-V to Starks. And we made the front end work, we made the back end work, we made the middleware really basic so that we can already make proofs for Rust programs, for example, or any program that compiles to RISC-V or Valida VM. Now that we have Valida as well. So now the middle is not finished. So the core of the compiler is not finished, but it has the bare features needed to go all the way from a Rust program to a Halo 2 proof, for example. And then this enables us to basically keep working in a way that's very feature or like use case based. So we have a certain program we want to make proofs for. We just try it because the parser works, the compiler works, the prover works. And then we figure out, okay, so there's a certain feature missing inside the compiler. We just go and build that feature. And because everything's very modular, it's possible for us to follow this approach and then just build out each feature separately until a certain use case we really want to work actually works. And yeah, I think this is basically the key to your first question. How do we go about building what sounds like a massive project? It's really based on this, I would even say, classic compiler architecture of layers, levels, and modularity.
I think that even applies to anything or any kind of project, startup, etc. It's oh, sorry.
Yeah, I was just agreeing with you. For sure.
Oh, sorry. Yeah, I think that goes with anything really. It's just you got to modularize, otherwise you're never going to get to the end, or at least the start of the journey. You'll always be trying to add all the features at the start and never actually reach the point where you can start iterating on it because you haven't got the initial product right. And given that you need to get to this MVP state, I guess how do you determine what is absolutely essential to include, and then how do you attack each kind of section of, okay, we need this first to make this other thing happen, and then we can finally use that last thing to get to MVP. So yeah, how do you decide on priorities and not trying to include every single feature at the first stage?
Yeah, so we basically decided we're not focusing on performance at the moment. This is something is going to come later, but it's not the main thing for now. So for now, we want to focus on developer experience and the usability aspects of going all the way from a high level program or from writing your own VM to a proof system. So currently we have a few fronts going on. So we have the front end, which again supports things like RISC-V programs and validator programs and soon EVM, WAS, and so on. So a big part of the work is making sure that these front ends are fully supported. And this is basically demand, right? So we know people want to make proof for robust programs. What's the easiest way to make proof for robust programs? Either RISC-V or Valida. But we also know people want WASM programs and they also want EVM because everyone still wants EVM. So I feel like these are the main front ends we have. And then inside each front end, we know what to do. And then it's kind of like quote unquote, just work. On the other extreme, we have the proof systems. And the main production proof systems we have nowadays are Halo 2 and Starks, right? These are the ones used by pretty much, I guess, all or almost all L2s, L3s, and so on. And so we focus on these two. So we have now Halo 2 integration almost fully done. And then we're also working on the Starks integration. And we also know people they want to verify proof in Ethereum. So if you're on the Stark land, you also need to have some recursion aggregation set up to end up with the snark that you can go and verify in Ethereum. So it's again based on use case and user demand pretty much. And then the internals of the compiler is then what's the minimal set of features that we need to write that's going to enable this whole thing to link together, right? How do we actually take all these front ends we want and link them to the back ends we want? So that's basically how the feature set is decided.
And you also mentioned like language design as well, right? I do want to touch on how do you actually know when a language is good? And, obviously you've had experience with, Solidity, that compiler. What are the things you've kind of learned from Solidity and you're kind of improving on with Powdr?
Yeah, I think there are quite a lot of lessons from Solidity. I think one big lesson is to keep it simple, which sounds very simple, and again, it's a general software engineering concept, right? To not try to make things too complicated if you don't have to. And I think this is one really positive point of Solidity. It's a DSL. It's made for Ethereum. It does its job. You can very easily read Solidity. You can, if you code in any Web 2 or systems programming language, you can learn Solidity in 2 days and start writing even slightly complicated things. Of course, you have to study the EVM as well, because if you don't know the EVM, then you're going to do weird stuff in Solidity. But I think Solidity does a really good job at being simple and effective at that and really easy to read and write. One of the negative things that I would say we've also learned from Solidity is to try to keep things out of the language, out of the compiler and written in the language. So this is one thing that like Rust does really well, for example. A lot of the things are written in the language itself. So tons of the libraries of many different things are written in Rust itself. And the compiler only needs one specific module or type checker type of module to support a whole set of different features because it allows these things to be written in the language. And in Solidity, there's a lot of magic things that the compiler has to support because these are things that are first-class citizens in the language. And I think reducing the set of first-class citizens in the language is also something we try to apply in the Powdr IR as well. Of course, sometimes it's hard to keep this principle 100% for practical reasons. But I would say this is like one big positive, big negative that we keep in mind.
Since Powdr is a startup, luckily you've found some co-founders, but what are the real difficulties you're facing as a startup? Obviously, you're juggling multiple hats, but starting up is not easy. So how are you kind of going through this process after going with Solidity? And I'm sure you've done previous startups, but yeah, I guess what have you learned in the past that you're now applying now, and what are you learning while building this right now?
Yeah, I think especially in the ZK space, it feels a bit hard sometimes to stay focused because there's
so many new things, right,
going on. And every single week there's a different proof system or use case, or I don't know,
Mm,
some crazy tool. It's really hard not to get nerd sniped constantly
hmm.
and go build different things just for fun. We're still doing this for fun, so we enjoy what we're doing and we think it's valuable.
Yep.
There's fun things everywhere to be done, and I would say this is tough. Just like deciding on the roadmap and really sticking to it, and not
Hmm.
letting yourself be distracted by either a new shiny thing that you've seen or different use cases, which we do learn about use cases all the time.
Mm.
I would say it's hard not to get distracted.
I definitely resonate with that. Building my fuzzer, I also talk to like AI engineers, and then I get extreme FOMO of of AI and feel like what I'm doing now is pointless. But after doing it for so long, it's like, why would I stop right at the end? May as well get to the finish line. But getting to the finish line is it's the hardest thing. Uh, the finish line meaning MVP at least.
Right.
Because the hardest thing really is getting to the MVP. There's so many distractions, so many things that can go wrong, and even if you get to the MVP, right, people might not even want to use it.
Yep.
Like maybe you've just built out a ton of features that nobody really uses, or maybe you use 1 out of 10, for example, and it's just like, oh wow, why did I just spend all my time doing this? Um, so I guess on that note, how do you know without, let's say you didn't have a community behind it already, you don't already know kind of what's necessary and what's not. How do you identify, what people want um, without, I guess, even having the people to begin with? I guess it starts from a problem that you've had or something you identify, and then you go through that. But then even then, you don't know if people would also have that problem. Um, so I guess where does that mindset really come from?
Yeah, I think you're right. At first, it was basically a problem we had, and we're trying to solve. But also at the same time, we know a lot of people. We have friends working on different levels of the stack. So on
Okay.
proof systems and cryptography, on L2s, L3s, and L1 itself. And so I think we've also identified from this larger community the needs of different things, and
Hmm.
also just talking to people in general. Especially, we were in Paris for HCC a few weeks ago, and I've heard of use cases that I have not imagined before, and that could potentially use Powdr as well, for example. And I think just always learning about different projects, different tools, different ideas, and besides the
Yeah.
ones that we already kind of knew before.
With formal verification, just to like jump a bit back, what are your thoughts on like the AI future of, I guess, FB and cybersecurity in that sense? Because it is quite intimidating of the possibilities of what the future can be with AI, and that can obviously bring in some imposter syndrome of, oh, what I'm doing right now is redundant. AI will eventually take it, but I guess, do you think about that at all? Of this huge AI revolution and it taking over software?
Yeah, I think on the FB or security side in general, I think it would be really cool to see more AI powered tools.
Yep.
I think there are definitely some up there already, both in like helping you construct the code, right, but also analyzing code. I think a lot of people are extremely skeptical, saying like, "Oh, there's no way AI can do what our current tools do," and yeah, that's probably true right now, but maybe one day we're going to be at a point where the AI is actually pretty good at like very quickly identifying vulnerabilities and this type of things. The one issue that it's also true for like the current AI already, just like the how confident you can be on whatever the AI says.
Mm,
And this is particularly a problem if in the security space, right? If the AI tells you, oh yeah, this thing is safe, and then it's like, yeah, okay, but why and how did you find it out? And I
mm,
think getting explanations out of AI is still a big research field. And I'm again, I don't know that much about AI, so I
mm-hmm,
don't know how advanced this field is, but I know that it's a field people work on. So getting like explanations out of AI decisions and
mm-hmm.
thoughts. So I think this is something that has to be figured out before people really trust AI results for security. Of course, for the positive case, in the sense of like the positive being a bug is found, the AI, if the AI gives you a bug, then of course you can just test it, right? So I think especially this case might be very valuable in the near
Hmm.
future.
Yeah. I think it's always great to hedge. Well, not hedge, but always try and learn a bit about new technology, including ZK, AI, whatever, because I mean, I think in the long run, it's about the things you regret that you want to. Well, if you want to start something, think about the future. Will I regret not learning this now or down the road? Obviously, there's a lot of trade-offs in opportunity costs. You might be focusing on startup and you don't really want to learn something part-time, but it might be useful, right?
Yeah.
But I think, it all comes down to time management, priority management, all that stuff, including, whether you're focused or not. So I guess, to achieve such great things, what do you really take? How do you really structure your day so you can focus, 100% at times and really structure your day where you can be most optimal?
I think still in the AI thing, really don't know much about AI, and I feel like I'm not the best person to get into AI, but I like to use it. So I do use
Mhm.
GPT-4 daily to help me out with things. I feel like it's not very good at code yet, but
Mm.
I use it just to like chat about ideas and ask
Yeah,
for
yeah.
information, like a Power Google kind of. I feel like it got more productive since I started doing this. I feel like a lot of people do that already, so it's nothing magic. But I think for me, it works. In general, I think being productive. Let's see, fewer meetings, definitely.
Oh, yeah.
I have a self policy right now of like Monday and Fridays, no meetings.
Hmm.
And like, of course, you can always have spontaneous meetings with the team and then discuss. We have ad hoc technical calls all the time, but just like no planned meeting. So like you can start and end the week and like in a focus way. I
Yep.
think focus time, like the chat close, is also a good idea. Um,
Hmm.
but also on the other way around, just like being communicative and then just like pair programming, these kind of things are super. I find it super productive to just work together with people on a feature or fixing bugs, reviewing pull requests, this kind of things.
Yeah, I agree. The pair programming thing is very useful. I haven't done it too much, but the times I have done it, you can really kind of like hone down and focus. It's like an environment you're in, right? So I don't know. Since you're talking to someone and discussing ideas, it's kind of hard to get distracted in that sense. Um, Whereas if you're alone, you have your phone, for example. Even if you have your phone in the pair programming, it's still not going to get as distracted as if you're alone and you have your
Yeah,
phone,
for
right?
sure.
And even just like managing social media as well, it's such a massive thing, right? And it's grabbing all your attention, or at least attempting to. And you got to find these windows within your day of focus, right? And that takes maybe 20 minutes to get into that kind of state, and it's so easy to break it. Um, so how do you really limit distractions? Because obviously you can work hard, but to get into the state of working hard and being in a flow state is the most difficult thing, I think, or at least that's for me. So I wonder what your kind of strategy is to limit these distractions and really zone in to the task at hand.
Yeah, I think when I really want to get something done, I don't know. I feel like it's kind of natural. If I'm really into a feature and then I just really want to finish it or fix a bug or something, then I feel like that itself is the thing that's nerd sniping me to do right now. Just like get nerd sniped by my own features. I think this is the usual mindset.
For me, I have the features. I have the same kind of feeling with some features, but then others are just extremely hard to implement, and then I get kind of like demotivated in some way. Do you
Yeah,
ever feel that kind of way?
yeah, for sure. Especially on the SMT checker stuff for Solidity for a long time. I was working on it alone. I had people like to discuss ideas and review pull requests and thing, but I was responsible for most of the implementation, and a lot of the
Right.
time the implementation was really complicated, and I had to like study a lot and design things. And at some point, all I could think of was like, I just want to not do any of the complicated features anymore. I just want someone
Yeah.
else to do it, or I just want to be done with this. So I think, yeah, definitely can resonate with that. It's hard to always have to do the complicated stuff. This is for sure. Sure.
Yeah, it's pretty annoying that to move on to the features that you do want to do, you've got to do these very difficult ones, which are massive roadblocks, and you actually can't get around them because they are a necessity for these other features.
Yeah, I think
So I guess
good solution is to just have good teammates that can also do that kind of stuff, and then you can always just alternate. And
yeah. But for the people that are building tools by themselves, I
this is
guess
hard.
yeah, it's incredibly hard. For me at least, I'm building a feature right now which is a necessity for everything else. But it's very it requires a lot of moving parts, which maybe is a flaw on my end for designing this in such a way, but I've also thought of different ways. But the overall kind of vision for it needs to be complex to some degree to even achieve it. But again, it could be just that I'm limited in my knowledge of software. But getting through these very difficult problems are extremely hard.
Yeah, no,
And
it's definitely tough. Yeah, and
but I
working
guess
alone itself, even if you're doing small features, easy stuff, just like working by yourself is always tough.
yeah. But I guess rewarding as well in some ways. But um, just to shift topic a little bit, you're working at Spearbit, well, as a freelancer, I assume, or a contractor.
Yeah.
And what is how do you really go about the auditing methodology you take? How do you zone in to find critical vulnerabilities, right? Maybe there's a different strategy, but I guess what is your kind of process?
Yeah, I think there's a few things that I personally, or also the other people that I usually do these things with, do. I think one of them is really just like understanding what the thing's supposed to do. So that's why projects with like great docs and this kind of things is always like more. It makes your life easier if you can read a document and say, okay, so I understand what this thing's supposed to do. And obviously, if the code is well written, you can try to like match it conceptually and say, okay, this gives me a good feeling or not. And this is also kind of like there's also this element of like vibes. You just look into the code and then it's like, okay, this looks weird, this looks a bit fishy, and I'll investigate a bit more. Of course, there's like good practices, things people should be doing, things people should not be doing, and of course, you hunt those down. Usually, more like in a methodic way, where I just see like I have this checklist of things that I want to check, right? And this is normal. I think everyone will have their own checklist of like bad practices, good practices, and I think everyone has their own checklist. Probably companies have their own checklist as well, and you do this kind of things, but you also have this feeling of like when things are looking fishy or not, and then you kind of just like you can do vertical or horizontal, right? You can just like find a fishy thing and try and hunt it down, go into the rabbit hole all the way until you're either convinced that it's fine or you find a problem, or you're like, yeah, convinced enough that it's fine. Or you can basically just try to like take a shallow look into the whole code base and then just kind of like scan, feel the different parts. And I think it's always a combination of both, right? So it's more just like you're always kind of like scanning and then you see, okay, this looks a little bit weird. So you go a bit deeper and then you scan a little bit as well. And then you either backtrack or keep going. Yeah, this is not very, what I just said doesn't feel very scientific, but yeah.
Having done it manually, you obviously have a good sense of, what goes into it. And, when you do it manually, it's an algorithm in your head, right? So I guess if you were to automate it, let's say in an abstract sense of very simple kind of things, like step by step, what would you do if you had to automate it? So what kind of like steps would you take to build something that could automate your process, or to a point where it can discover critical vulnerabilities in an efficient manner?
I think you mean automate the manual process, not like an FE tool.
Yeah.
I think like visualization tools help, or like better visualization tools would help, because I think sometimes projects have like really complicated paths inside their whole smart contract suite, where you're like, okay, how do we even get to this function? Okay, this function looks kind of fishy, and the way it's using the state variables, the storage variables, feels problematic, or it could be double spending ETH. But for that, I need to verify and I need to check that this path is unique, or like that it can branch out in a certain point. So I think there's probably a lot of heuristics that tools like Slither, for example, probably employ, also from their own learnings and audits. So I think those visualization tools would be probably something I would try to tackle if I was trying to automate this process. And I have used FE tools for this kind of stuff before. So like if I want to, I have a function that's really deep down the smart contract. It's kind of far from the entry point of the contract. Then how do I even get to this point? What are the functions that allow me to come here? Then it would just
Mm-hmm.
like put a broken assertion there, like assert false or something, and then run FE tools like HVM or Simply Check or others, and then see the counterexample and see, okay, this is how I get to this function, which feels like overkill in a way, but I think, I don't know, this feels like, yeah, one example that just came to mind.
Yeah, some more visualization tools. And I wonder, what if you had to fully automate it? How would you go about that then?
Wow, fully automated, then I would build an FE tool. Because I think if you're automating the manual process, it's a lot of heuristics that
Yeah.
you don't necessarily have mapped out in your head explicitly. So, I mean, as you saw before, I even have a problem explaining what I do manually because it feels very intuitive sometimes, and
Mm.
you don't know why you're doing things. Of course, again, there is this checklist, and you of course, like with experience, you know when things look fishy or not. But I think, yeah, automating the manual process, I just wouldn't know how to do it because what you're trying to do is basically, I think, yeah, the only way I can describe it is just like collecting heuristics and making detectors based on these heuristics. So again, tools like Slither, I feel like, yeah, tools like Slither are probably a good summary of things you usually check in the manual audit. So that's why I don't know how I would go about doing that besides doing what Slither what already does, and fuzzing and these kind of things. Of course, like sometimes we do set up our own fuzzing based on like whether we want to prove equivalence of different reference implementations or these kind of things.
Mm.
But
Yeah.
if I had to build a tool to automate a whole security process, I would probably build either a fuzzer or an FE tool.
Got you. Yeah. I mean, building something that fully automates finding I guess, vulnerability is not an easy feat. As you said, it's a bunch of heuristics and ways of thinking, which get complicated very quickly. And, first of all, you have to build the reconnaissance tool to kind of get all the information right. And then you got to start building, you got to account for all the different scenarios or what can happen, what things can change, what can be influenced. And, with smart contracts, it's a multi-dimensional kind of problem. It's not, traditional fuzzing where you just change the payload. It's more of, changing the payload, that's one, but then you also have cross-contract interaction.
Yeah.
There's different contexts of all this stuff as well. Like someone can throw in, 100 ETH to the contract. Then what happens to all these other paths I just took with this 100 ETH? So there's also like active fuzzing as well, and then replicating all of the past fuzzes with this new actor. So there's that dimension as well, and then even you can say cross chain or multi chain, omni chain, whatever. Um, Maybe it depends on off chain stuff. How do you modify that? And then it becomes an even bigger kind of problem.
Oh yeah, for sure.
So in my eyes, it can be done. It's just a very tedious thing. Um, and that's where I think AI would really come in. Because if you think about it, any kind of fuzzer, anything is really just a representation of your manual labor to build the tool first of all, but it won't evolve unless you evolve it. Whereas an AI can evolve by itself and understand all these dimensions intuitively after tons of training. I don't know. It's an interesting field, and I think it's definitely worth taking a look at. I do eventually want to get into like formal verification, well, not formal verification, but I guess fuzzing on ZK, especially on like Aztec. That seems very interesting. With like, you have ZK with the privacy transactions, but then you also have like abstract, the abstract account abstraction. So it's like a whole new kind of realm, I think, for people interested in EVM, Ethereum kind of stuff. Having said that, it has reached 1 hour, and I don't want to take too much more of your time. I do want to thank you for jumping on for this past hour and being able to connect with me, and hopefully you've enjoyed it as much as I have. But yeah, thank you so much for coming on.
Yeah, for sure. This was a great chat. Thanks for having me on.
Of course. And for anyone listening, if you want to be on the podcast or want to suggest anybody coming on the podcast, just DM me at scrapingbits on Twitter. Otherwise, thank you so much, Leo, for jumping on, and I'll catch you all on the next episode.
For sure.
Yeah.